so it's good to see you all here again. I'm Natasha and welcome back. So today we're going to continue our chapter number 2, relations and functions. So in the previous video, we discussed about the functions and their graphs, like identity function, Signum function. Oh, actually we haven't discussed about Signum function, isn't it? Yeah, we haven't. So, but yeah, in today's video we're going to discuss about it. So we've discussed about identity function, rational function, polynomial function, and constant function. Yeah. So in this video we're going to discuss about modulus function and Signum function. Okay, so let's get started. Okay, so first topic is about modulus function. So, like, what is exactly modulus function? So, what is modulus function? So, first of all, let me write modulus function. Okay, modulus function. So, what is modulus function? So, in a simple way, I'm going to say this is kind of a function which gives the absolute value of a number or variable. So, like, what does that, what does a number mean? Like, what kind of number are we talking about in this function? So, let me just show you with the help of the graph. Okay, so this is the graph, and we have two axes, the x-axis, the y-axis, negative y, and negative x. So, and in x-axis, I'm gonna write, this is gonna be the origin, 0, 0. So, and just right here, I'm going to say 1, 2, 3, 4, and 5. Then right here, I'm going to say negative 1, negative 2, negative 3, negative 4, negative 5. And right here, I'm going to say negative 1, negative 2, negative 3, negative 4, and negative 5. Okay? Okay. So, and right here it's going to be positive. So, 1, 2, 3, 4, and 5. So, just wait a second. Here we have 4. So as we can see, this is gonna be our graph. And what is modulus function? So the modulus function is gonna be like a little different way. So just let me tell you. So first, just let me write the statement for the modulus function. So it is a function which gives the what? So it gives actually, first thing that we have to remember that in modulus function, we're always going to be talking about a variable or a number, okay? So what is modulus function? So it is a function which gives the absolute value of what? Of a number or variable. That's it. So it is a function which, just wait. So it is a function which gives the absolute value of a number or variable. Okay, just have a look at the short statement. Okay, So it is a function which gives the absolute value of a number or variable. So first of all, like, what does this absolute value mean? Absolute value of a number or variable. So it gives the absolute value of a number or variable. So let's just understand it by first of all, it's like this is kind of be like an example, which I'm just going to take. Okay, so let's take f of x. As we all know that this f of x is equal to y. So what I'm going to say is that y is equal to f of x, which I can also say fx. Cool? All right. So fx is equal to the mod of x. The mod of x. Now I think you'll understand about it. Now I think that this topic will be clear to us. Modulus function is actually a function which is going to give that absolute value of a number or variable, we can say, as we're using a variable. So it's just going to tell us that if fx is equal to the mod of x, so fx is equal to the mod of x, and to the other functions we have said that y is equal to fx. But in this condition, it's kind of like a little different, okay? So fx is not equal to y right now, okay? Is not equal to y right now in this function. So as we all know that this x is going to be the input value, as we can say if it's going to be input value, like in normal cases, what do we say? The x as input value and the y as output value. So what I'll say, x is going to be the domain and y is going to be the range. In just simple words. Okay, so let's try to understand this. Fx is equal to mod of x. So it's just simply saying that if we have the domain, if we have the domain is equal to real numbers. The first thing that we have to remember is the domain is equal to the real numbers and range is equal to the positive real numbers. So what does that mean? The positive real numbers means non-negative integers will be included, like nothing negative, only everything's gonna be positive. So only the positive real numbers. So the range is equal to the positive real numbers. So what this exactly means? So what I'm saying is that the fx is equal to, let me just make something, negative x if x is smaller than 0, positive x if x is greater than 0. Just have a look at this thing, like what is it exactly? What is it exactly? Okay, let me write it in the form like in positive first and then negative. Just want to tell you something related to this thing. Okay, positive x and x will be greater than 0. Negative x if x is smaller than 0. This is the one thing that we'll see. Okay, so in the modulus functions, the functions are gonna be exactly what am I trying to say? Is so the domain will be range. The domain will be real numbers. Yeah. So domain is equal to the real numbers and range is equal to the positive real numbers. So this simply just means, let's say x, y. And always remember that x always be positive. Okay? It's always going to be positive. our y, which is the range, is always going to be positive, okay? As it's going to give the absolute value. So if anything comes in the mod, which means that if it's the negative value, like it's going to change its sign, and you know, it will always going to be positive. So if I'm going to say that x is equal to -1, x is equal to -2, x is equal to 0, 1, or 2. Can you just guess like what will be its exact values in the y? What will be in the y? It's just really simple. It is just really simple. So it's gonna be the negative value, which is always going to be positive. So it will be 1, this will be 2, this will be 0, this will be 1, this will be 2. So exactly just the same. But what about this thing? It is saying that if x is greater than 0, okay? That's it. In negative x, if x is smaller than 0. So what I will say, like in this form, it just say like we always have to remember that that our range, which is y, it's always going to be positive, okay? So the negative sign will not be included. It's always going to be positive, okay? So in the graph form, it's going to be it will just be going like this way. So these two lines for me, just write in these. So this is what I'm saying, that the negative will be also positive. Got it? Is it clear to you? So it's just a function which is going to give us the absolute value of a number or the variable we're having right now. Okay, so just have a look at the graph and all the things about the domain and range. Like it should be clear to us. Okay? Yeah. So like I'll be like using this thing in the questions whenever like I'll be solving questions, I'll use this thing. I'll use this point. And yeah, like we have to remember this thing. Okay? X. And it's saying like x, positive x, if x is if x greater than 0, negative x smaller than 0, then the negative x we're having, isn't it? What if I say that in the modulus function, if we're going, suppose if I'm going to say that, okay, this is a really simple question, that in the modulus function, can we have a complex number? Of course not. Of course not. Like we can't have complex number. It's just a really easy question. Because like the function's all about the real numbers. Like if there is any complex number, that would be like really disaster. Yeah, it's really going to be like something which is not related to that topic. So like we just have to forget about the complex number. Just only we're going to think about its real numbers. Wherever in the function we'll be seeing only real numbers for now. Okay, so doesn't matter to the complex numbers will not come. As in the graph, we're only going to have these negative numbers and these positive numbers. That's it. Okay, so let's move on to our second function that I'm going to discuss with you guys is Signum function, okay, which you can also say as SGN. Isn't it? SGN as Signum function. Okay, so let me rub the board and then we're going to discuss about it. And let me rub these two lines also. Okay. So I'll be rubbing everything. And then I'll be discussing about Signum function. I'm almost done. Almost there. Okay, so I'm done, and let's discuss about Signum function, which is going to be our sixth function. Signum function. Okay, and just let me draw this graph. Okay, it was just like this way. Okay, so whatever, it's perfect for me. Okay, Signum function. Now we'll be discussing about Signum function. So it actually, in simple words, it helps in determining the sign of the real value function. So it helps in determining the sign of the real value function, like whether it's going to be like if I want to say that, like, is it going to be negative or positive? So something like this case, something like this. So Signum function, this function helps in determining okay, it helps in determining the sign of the real value function. The real value function. It helps in determining the sign of the real value function. Whatever you can say, determining, that's your choice. Okay, it helps in determining the sign of the real value function. So what does that mean? So it's just going to determine the sign. That's it. And the real value function we're having. So let me just say it as an example. I'm going to tell it something as an example. Yeah, so it's actually like an example. So let's talk about fx. Okay, fx. So in fx, I'll be drawing something. It's not an art, of course. It's not an art. So oh, wait a second. Let me just write it in the most simplest way. Oh gosh, these braces. Okay, yeah. So fx is equal to 1, comma, x is greater than 0. 0, x is equal to 0. Negative 1, if x is smaller than 0. Just have a look at this, what is this exactly? So it's saying 1 if x is, greater than 0. 0 if x is equal to 0. And negative 1 if x is smaller than 0. Like, what's this? So, first thing, if we're going to talk about the domain is going to be the real numbers. But about the range What about the range? Range is only going to be 1, 0, and -1. That's it. That's it. So this is what I'll be having. And if you want to see it in the graph form also, then let's just have a look. Okay, let's just have a look. So I'm going to draw something right here and something right here. Okay, just have a look at these two lines. What are they trying to express? Y is equal to -1, y is equal to +1. Just have a look at this graph. So in the first case, in upwards, it's saying that y is equal to 1 and y is equal to -1. Okay? Okay, so let me just rub these numbers. We're not talking about the number, or maybe okay. I'm gonna draw the graph again. In this case, we'll be not talking about those numbers. That's it. Just a simple graph. Okay, x, y, -y, -x. Okay, let's say here at this point we have 1. And here at this point we have -1. Okay, so this point saying y is equal to +1, and this point saying y is equal to -1. And this is where we have our origin. Just have a look. This is where we're gonna have our origin. This is it's saying y is equal to -1 and y is equal to +1. What does all this mean? In a simple way, what does all this mean? It's just really simple. We're talking about something. So, as we all know that 14:35. Ugh. Okay, as we all know that x is going to be, x is going to be our input value, which is going to be the domain. Y is going to be the range, which is going to be, which I can also say as output value, okay? So, it is saying that this x, the domain is equal to range. Sorry, not the range. Why do I always say range? I don't know. Okay, so domain is equal to the real numbers, not range. Yeah, not range. Okay, so in the Signum function, so it's just really simple. As we can see that we have we're having only 3 numbers right in the range. 1, 0, -1. Why? Because we can see this from this, this thing which is just written here, okay? I'm not going to say anything for now. It's just something related to Signum function. Signum function, SGN. Okay, so the domain is equal to range. Real numbers, real numbers, real numbers. I'll not forget. Okay, so domain is equal to real numbers. Okay. Yeah, this time I'll not make mistake again. Again and again saying range, range, range. But it is not range, it is real numbers. Real number. Okay, I think now it'll be clear. Okay. So it is saying that the domain, which is going to be x, so x can be any real number, the domain can be any real number, but the range is going to be, you know, I'm going to say it's actually fixed, it's permanent. There will be only 3 ranges, 1, 0 and -1. That's it, nothing else. No other range will be, no other elements will be included in range. Okay? So, our range is permanent, but our domain can be any real number, as we can see through this. Like, if I'm going to talk about the positive one, which is in the positive, y-axis, so then I will say that x is equal to 1. But if it's going just downwards in the negative y, then the value of y will be -1. Okay? So it's just kind of points, like here we have 1, here we have -1, and here we'll have 0. Nothing else. So the range is going to be permanent, 1, 0, -1. And their domain can be any real number. So it helps in determining the sign of the real value function. So it's a Signum function helps in determining the sign of the real value function. So the real value function, we can say it for now is a y, and it's just like telling us the sign. It's like determining it's determining the sign, whether like if it's like a 1, positive 1, -1, 0. So one thing that's going to be permanent is range is going to be 1, 0, -1, and domain can be any real number. So this is what we have to remember in Signum function, and especially this thing. If our x is greater than 0, then it's going to be positive 1. We have to always remember. So if I'm going to say that the value of y is 1, or if it's, let me say y is equal to 3. Then I will say that the y is equal to 1. That's it. And if I say that y is equal to -4, then it's going to be -1. And if x is equal to 0, if our x value is 0, then it's going to be 0, nothing else. Okay, it's just related to the positive, the negative, and only about the 0. So this is what we're going to have. If y is equal to positive 2, it's going to be positive 1. The range is going to be actually in the positive 1. And if y is equal to, for this case, like if x is greater than 0, then it's going to be 1. X is equal to 0, then it's going to be 0. And x is smaller than 0, then it's going to be -1, nothing else. Okay? Range is fixed. Domain is, it can be any real number. So this is what we discussed in Signum function. So, and in the graph also we did, we didn't need any numbers here to draw them, okay? Because they're they're not related to this topic. Okay. So, that's all for today. We discussed only about 2 functions. So that is modulus function, Signum function. So in the next video, we'll be discussing about greatest integer function. We can say, which we can say as GIF. GIF, I've heard about this. So we can call the greatest integer function as GIF, GIF, So we'll be discussing about this function in our next video. So, thanks for watching and have a great day.